The year was 1998, a respected European gem laboratory received a parcel of rubies. They were stunning, their color was a vibrant pigeon's blood red, their clarity was exceptional. On initial examination they appeared to be high-quality natural stones from the legendary Mogok stone tract in Burma. The lab issued its certificates. The gems entered the high-end market destined for exquisite jewelry pieces. Yet a nagging doubt lingered for some. A few months later the truth emerged, sending shockwaves through the industry. The stones were not from Burma, they were synthetic, created in a laboratory using a sophisticated flux growth method. That mimicked nature's process with unnerving accuracy. Even seasoned experts were fooled. This incident serves as a stark reminder: what glitters is not always genuine. The line between nature's art and human ingenuity is often blurred. Geochemistry is, at its heart, the study of the chemical composition of the earth and its rocks and minerals. For a gemologist, it is the ultimate detective science. Every natural gemstone is a product of a specific geological environment, a unique recipe of pressure, temperature, and chemical ingredients that cooked for millions of years. As a crystal grows, it incorporates tiny amounts of other elements from its surroundings. These trace elements are like geological DNA. They tell a rich and detailed story about where, when, and how the gem was born. A ruby from Mozambique, a ruby from Burma, or a ruby from Tanzania. This concept of a chemical fingerprint is the cornerstone of modern gem identification. While two rubies may share aluminum oxide, their trace element profiles are worlds apart. Chromium, iron, titanium, trace elements influence color and fingerprint. Laboratory processes are too clean compared to the messy chemistry of nature. By analyzing trace elements, scientists can often link a stone back to a region, essentially an unforgeable passport. A sapphire from Kashmir is prized far more highly than a similar-looking stone from elsewhere. Geochemistry transforms gem identification from subjective art into rigorous science. The secrets are there, locked inside the crystal, waiting for the right tools to bring them to light. To read the chemical stories hidden within gems, scientists employ a suite of powerful analytical instruments. Each offers a unique window into the stone's atomic world. One workhorse is X-ray fluorescence, or XRF. It is non-destructive, critical for priceless gems. The instrument excites atoms which emit characteristic secondary X-rays that a detector reads as a spectrum. For deeper analysis, technicians use LA-ICP-MS. A high-powered laser microsamples a microscopic spot. The vapor is ionized in a plasma hotter than the sun and measured by mass spectrometry, parts per billion sensitivity. FTIR shines infrared light and measures absorption, ideal for detecting organics and water in gems. Raman analyzes scattered light shifts to give a molecular fingerprint and identify microscopic inclusions. FTIR can reveal fracture-filling polymers in emeralds and water-related peaks that indicate natural origin. Raman and FTIR together can help determine natural versus synthetic diamonds and detect treatments. LA-ICP-MS produces elemental concentrations and depth profiles, invaluable for diffusion and surface layer detection. Combined datasets build an irrefutable case for identity and origin. Non-destructive techniques are preferred wherever possible to preserve value. The battle for authenticity has shifted from the jeweler's bench to the scientist's laboratory. Each technique brings a different lens. Together they let us read a gem's atomic story and separate nature from imitation. The ultimate truth isn't on the surface, it's encoded inside. The concept of a chemical fingerprint is what truly separates a natural gem from a lab-grown counterpart. Nature is a messy chemist. When a ruby forms in marble deposits, it grows in a complex soup of elements. By contrast, flame fusion synthetic rubies are made from purified Al2O3 and chromium. Chemically simple. Chromium gives rubies red, vanadium and iron vary by host rock, and gallium signatures help separate natural from flame fusion. Natural stones carry a rich suite of trace elements impossible to perfectly replicate. Emeralds vary by origin. Colombian hydrothermal emeralds versus Zambian or Brazilian stones. Three-phase inclusions and trace sodium-cesium patterns are fingerprint cues. Flux-grown emeralds often lack water and may contain flux residues like molybdenum or nickel. Side-by-side comparisons reveal telltale differences, too clean or unnatural inclusions. For sapphires, the gallium to magnesium ratio became a reliable screening test. High-throughput labs use these rules to screen thousands of stones. Even organic gems like pearls carry fingerprints, trace elements from the water the mollusk lived in. Manganese and strontium ratios help distinguish freshwater versus saltwater pearls. No single test suffices, it's the tapestry of trace elements and ratios that builds provenance. This chemical language lets scientists act as translators of nature's story. The infiltration of undisclosed synthetics and treated gemstones has profound economic consequences. Those ripples travel from miner to final consumer. For the buyer, the impact is financial, thousands, sometimes tens of thousands. Discovering a stone is lab-grown can mean a tiny fraction of expected value. This isn't merely a bad investment, it can be fraud with emotional consequences. Sentimental value becomes tainted when deception is revealed. Honest dealers risk reputation loss and large refunds. Costs of verification and liability are real and often passed to consumers. The market effectively pays an honesty tax to prevent deception. Confidence falls and the value proposition of natural gems weakens. As synthetics improve, detection requires more sophisticated and expensive analysis. This destabilizes livelihoods across the supply chain. The sustainable path is transparency, education, and scientific verification. Reputable labs and clear disclosure rebuild trust. Without it, romance and wonder risk being replaced by cynicism, a high cost to pay. Science protects both value and the stories gems deserve. Beyond natural versus synthetic lies a murky middle ground, treatments applied to improve color or clarity. Some treatments are accepted, others are deceptive and unstable. Heating is one of the oldest treatments. It can deepen color and improve clarity. Heating alters inclusions and trace element valence states, detectable with spectroscopy. Emeralds are often fracture-filled with oils or resins to hide cracks. Modern polymers can closely match refractive index, making detection challenging without FTR. Diffusion treatments force elements like beryllium or titanium into a surface layer to add color. The color is skin-deep. LA-ICP-MS depth profiling can expose surface enrichment. FTIR detects organic polymer signatures of fillers. LA-ICP-MS gives depth profiles for diffusion. Together they reveal the hand of man beneath the beauty. Non-disclosure of treatments is the ethical problem. Buyers pay premium prices for misrepresented stones. Scientific testing and transparent reporting protect consumers and honest dealers. Failing to disclose treatments leads to returns, litigation, and damaged trust. Verification and clear disclosure are the remedies. Understanding and detecting treatments preserves value and prevents fragile artificial beauty from being sold as something it is not. Science protects both beauty and buyer. Definitive ID requires labs, but curious collectors can perform simple geochemistry-rooted screening tests at home. These are screening tools, not final verdicts. A long-wave UV flashlight is inexpensive and many natural minerals fluoresce predictably. Natural rubies often glow red, synthetics may fluoresce differently. An early clue. The fog test leverages thermal conductivity. Breathe on the stone and watch how quickly fog clears. Real corundum and diamond clear quickly. Glass and plastic fog lingers. A quick way to weed out cheap imitations. A 10x loop reveals inclusions, growth zoning, gas bubbles in glass or curved striae in flame fusion synthetics. Natural features like mineral crystals and growth zoning support authenticity. Absence of fluorescence isn't proof of fakery, some natural stones lack expected responses. Cataloging and simple tests are the first step. Use them to flag stones for professional testing. If results are unusual or a stone seems too perfect, consult a gemological lab. Simple tests help you avoid obvious pitfalls and increase your confidence as a buyer. These are observation tools, not definitive identification. Be curious but skeptical. If a stone seems too clean or reacts unusually to tests, get a professional opinion. It's worth the peace of mind. Let's examine chemical clues that unmask fakes in 3 popular gems: ruby, emerald, and pearl. Starting with the ruby. LA-ICP-MS shows chromium, vanadium, iron, and more. Patterns differ by host rock. Flux-grown rubies may show platinum or iridium contamination. Elements rare in nature. Emeralds formed hydrothermally trap water, OH, in specific channels. FTIR detects this. Flux-grown emeralds often lack that water signature and may show flux residues. Colombian, Brazilian, and Zambian emeralds show distinct alkali metal signatures. Natural inclusions like mica help fingerprint origin. Pearls form organically. X-radiography reveals natural concentric growth rings. Cultured pearls show a bead nucleus and thinner nacre. Natural pearls show onion-like rings. High manganese suggests freshwater origin. Strontium complements the picture. It's the combination of methods that builds an irrefutable identification. Ruby trace element tapestry, emerald water peaks, and pearl internal structure, each a unique language. The scientist's job is to decode these signatures. For ruby, look for Mo, La, W, PT, PB, Bi as synthetic flags. Natural marble-hosted rubies show high V and low Fe. Combine element lists, depth profiles, FTIR and Raman to build the final case. The gemstone world sits at the intersection of art, science and history. Science doesn't diminish magic, it protects it. Ask about origin and treatments. A reputable jeweler will welcome these questions. Request a respected lab report, GIA, AGL, Gubelin or equivalent. Get a loupe, look for tiny imperfections. The jardine that testifies to natural origin. Learn inclusion types and compare side by side with reference materials. Use simple tests as initial filters. Then send suspect stones to labs. Share findings and educate the community to raise collective defenses against deception. Trust professional lab documentation over informal in-store appraisals. Transparency builds market pressure that sellers cannot ignore. By valuing provenance, we protect miners, cutters, dealers, and buyers. An informed consumer is the first line of defense against fraud. The chemical fingerprint in each natural stone is a microscopic masterpiece millions of years in the making. Trust the science, be curious, and let verification replace doubt with wonder. Have you uncovered a fake or confirmed a treasure? Share your stories in the comments and check out Ricardo Valls' other videos on modern exploration and MLAI and geosciences. Subscribe for more, and keep asking questions.
Welcome to my channel, where you'll find over 2,000 videos on geology, geochemistry, AI, and many other subjects. If you like what you see, help us grow by subscribing, liking, and sharing this channel.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.